Hi students, this is Mr. Yang. Today we are going to talk about stretches, another form of transformation. It is actually very similar to dilation. We have learned that dilation changes both the x and y coordinates, which in other words, dilation is a two-dimensional transformation. Stretch, however, is a transformation that changes the size of only one dimension of the figure. So it could be a vertical dimension or a horizontal dimension. But since the size changed, stretch is still not a rigid transformation. It still only creates similar figures, not congruent figures. In other words, size, perimeter, and area are not preserved, just like dilation. Stretch is basically dilation in one dimension, so we still use scale factor to describe the size change from the original figure to the image. When we want to describe the stretch, we're going to need to use the direction, which is going to be vertical or horizontal, and we're going to use the scale factor. For example, vertical stretch of 1.5. That's kind of how we describe stretch. As for how we graph an image using a stretch, it's still very similar to dilation. Write each vertex as an ordered pair first, and then we are going to multiply either the x-coordinate or the y-coordinates of the vertices by the scale factor. So now we do need to be able to tell apart when do we use the x-coordinates and when do we use the y-coordinates. If the question said it's a vertical stretch, we are going to change the y-coordinates. If it is a horizontal stretch, we are going to change the x-coordinates. And lastly, we just need to plot and label the image points. Now let's have a look at a few examples. Example 1. Vertical stretch of 2. Let's write down the original points first. We have m, that is -2, 2. We have n, that is 1, 2. We have o, that is 2, 1. And we have p, which is -1, -1. It is vertical stretch, so that means we are going to change whichever way is vertical, that would be the y. So we're going to change all the y values, multiply them by a 2. So that gives us m prime as -2, 4, which is right here. That's m prime. Again, don't forget to label them with the prime. Then n prime, the x does not change, still a 1. 2 times 2 is a 4. So n would be 1, 4, which is right here, n prime. O prime is going to be 2, then multiply the y value by 2. 1 times 2 is a 2. So O would be 2, 2. That's O prime. And then p prime, -1 stays. The -1 times the 2 is going to become a -2 for the y coordinate. So it's got to be a -1, -2. That's my p prime. Lastly, connect everything. To n and to m prime to n prime, n prime to o prime, and o prime to p prime, and lastly p prime to m prime. And that is a vertical stretch. Example 2, horizontal stretch. Same idea. Let's start with the original points. We have R, which is 2, -1. We have S, which is -1, 2. And we have Q, and that is 1, 5. It is a horizontal stretch this time, so we are going to change the x coordinates. R prime, 2 times 2 is going to be a 4, y stays. The S prime, -1 times 2 is a -2, and the 2 stays. Lastly, Q prime, 1 times 2 is going to be a 2, and the 5 stays. R prime, 4, -1, right here. S prime, -2, 2, right here. And Q prime is 2, 5, which is right here. Let's connect S prime to R prime to Q prime, and Q prime to S prime. In case you didn't notice, this is quite different from dilation. In dilation, your image, the size of your image is basically parallel to the original shape. But for here, we can't. They are actually different. They are not parallel. So that's something about horizontal stretch and vertical stretch. Example 3, a vertical stretch of 1/2. Let's start with the original shape. I have 1, 2, 3, I have size 5 points, so let's write them down. My T is going to be -3, 4. My U is going to be 2, 3. My v is 1, -2, my w is -2, -1, and my x is -4, 1. It is a vertical stretch of 1/2. That means we're going to change all the y values to 1/2. Start with t prime, that is -3, 4 times 1/2 is a 2. That is my t prime. Next, u prime, the 2 doesn't change, the 3 divided by 2 is going to be a 1.5 or 3/2. So my u prime would actually be here. Now v prime, 1 stays there, and the -2 times 1/2 is going to be a -1. So v prime is right here. W prime, same thing. The x does not change, stays as a -1, but the y would change from a -1 to a -1/2. So -2, -1/2, W prime is around here. Lastly, x prime, -4 and 1/2. So it's going to be right here. That is my x prime. Now I just need to connect them. T prime to u prime to v prime, v prime to w prime, and w prime to x prime. Lastly, x prime to t prime. That's my general vertical stretch for example 3. Now let's talk about the stretch coordinate rule. If you recall, dilation would be x comma y changed into kx, ky. So we are multiplying the k by both the x and y. Now for stretches, again, it does have a direction. So if it's a vertical, that means the y value is going to be multiplied with a scale factor. If it's a horizontal one, that means the x coordinate is going to be multiplied with a scale factor. Now let's have a look at a few examples again. Example 4. It is changing into x, comma 1.5y, which basically means it's going to be a vertical stretch because the y values are changing. Let's write the things down first. A is 0, 3, B is 3, -1, C is 1, -2, and D is -3, -2. So vertical 1 by 1.5, so I'm going to multiply all the y values by 1.5. That gives us A prime as 0, 4.5, which is around here. That's my A prime. Then B prime, 3, -1.5. 3, -1.5. That's my B prime. C prime, 1, -3, which is right here, C prime. Lastly, D prime, -3, and it's -2 times 1.5 is going to be a -3. So it's going to be right here as my D prime. A to B, B to C, C to D, A prime, B prime, B prime to C prime, and C prime to D prime. Lastly, D prime to A prime. Here is my vertical stretch on example 4. Example 5, start with the normal points. G is 1, 2, F is -1, -1, and H is 2, -2. This time we are changing all of the x values by 2.5. So G would be 2.52, which is around here. That's my G prime. And then F prime would be -1, -1, so it's got to be -2.5, -1. -2.5, -1, around here, F prime. And then for H prime, that's going to multiply the 2 by 2.5, so 5, -2. Yes, 5, and the y stays, which is going to be around here, actually. It's 5, -2. So there's my H prime. Connect them, F prime to G prime to H prime, and H prime to F prime. That's my example 5. Next, example 6. X does not change, the y is multiplied with a 1/2. That means my scale factor is 1/2. I just need to change all the y coordinates by 1/2. Let's start writing the original one. I is going to be -2, 1. J is going to be 3, 2. K is 3, not 3, 2. It's actually 2, 3. And the K is 3, -2. Lastly, L is -2, -1. Let me write a bit clearer. L is -2, -1. you just need to multiply all the y values by a 1/2. That's going to give us my I prime as -2, 1/2. I prime is -2 and 1/2, which is right there. I prime. J prime, 2 and the 3 is being multiplied by the 1/2, so it's got to be 2 3/2. That is my J prime. K prime is actually going to be 3 -1 right here, K prime. And lastly, L prime is going to be -2 -1. -1 times 1/2, so it's -2 -1/2. That is my L prime right here. So now it's time to connect them. Okay, that is example 6. Next, we are going to learn how to write a description and rule, just like the other 2 transformations we have learned. First, write the order pair. Again, you don't have to write every single one of them down. You just need around 2 pairs. Then you are going to divide the changed coordinates of the image by the coordinates of the pre-image to find a scale factor. It's still going to be the image divided by the pre-image. The only thing is, not all the coordinates are actually given. So you are going to need to see which one actually changed. Lastly, of course, describe the stretch in the form of a certain direction of stretch, of the scale factor. Now let's have a look at a few examples. Example 7. For this one, let's start with J. My J is -2, 1. My J prime is -2. That looks like 1.5. Okay. My K is 1, 2. My K prime is 1, 3. And my L in this case, that does look like it is 2, -1, 2, -2.5. Now it's time to decide on what kind of stretch it is. You can clearly see -2 does not change. 1 does not change. 2 and my other point, in fact, is going to be 2 -1. And you can see the 2 does not change. So all of these numbers, you don't need to find the scale factor. But let's use the other one. We are going to do the image divided by the pre-image. So it's going to be 1.5 divided by 1. I don't know why I wrote that as a -2.5. It's actually -1.5. And that is just 1.5. And if you use another point, the 3 divided by 2, it's going to give you the same thing, or the negative. Well, actually, that's our scale factor. You can choose to use 1.5 over 1, or you can use 3 over 2. That's going to give you 1.5 as well. Description, in this case, you can see the y value is the number that changed. The y is going to be a vertical stretch of 1.5. So we are going to need to write the rule, which means we don't change the x, but we change the y to 1.5 y. That is example 7. Next, example 8. Same idea. Let's start by identify some points. Again, you don't have to identify every single point. In fact, you just need around 2 pairs. So my A prime is 2, 2. My A is 4, 2. My B is 2, -1. And my B prime is 1, -1. D prime, D is -2, 5. D prime is -1, 5. And that should be typically be enough. Let's find a scale factor. We're going to need to use the image divided by the pre-image. This is actually the image. You do need to understand the image in this question is a kind of inside. So 2 over 4, that's a 1/2, that works. Or in this case here, -1 over -2, that's for sure 1/2. So the only number that actually changed would be the x that changed. So this is going to be a horizontal stretch of 1/2. As for the rule, x comma y, since x is changing, that means x is going to become 0.5 x, the y does not change. Why is it there? It shouldn't be a plus sign, just a comma in there. And now, lastly, example 9. Let's start by identifying points first. My B, in this case, it's 2, 1. My B prime is 4, 1. My D is -3, 2, and my D prime is -6, 2. So clearly, there is some change, and as you may notice, the y value does not change this time. The y does not change. They're both 2 and they're both 1. So that means it's not going to be a vertical change. In this case, it's got to be a horizontal change. And we're going to use the image divided by 3, so it's -6 divided by -3, which is a 2, or 4 divided by 2 is a 2. So the description would be, in this case, since my y stayed the same and my x is changing, it's going to be horizontal stretch of 2. Rule x comma y arrow. In this case, the x is changing, so the x is going to be multiplied with the scale factor of 2, 2x, and then comma y. And that is example 9, and that concludes this lesson about stretch. Thank you.